and this one is another one, but they are two. Their connection is important, and we are going to discuss about that. What is the rating of these batteries really means a lot. This one is actually a 12 volt 7 amp hour. When we come to this one, is the same voltage, 12 volt 200 amp hour. So why is that a difference, and what does this mean? We will talk about that definitely, my top boss. When it comes to the connection here at the terminals, we have the positive and the negative. Really means import a lot when it comes to DC or direct current, my top boss. And when you connect something directly to this, you find that there is that which is a bulb definitely, and once I disconnect it here, the bulb is off. Let me just demonstrate that, as you can see. And there's another important factor when it comes to DC, definitely the solar panel. A solar panel will definitely charge a battery through various means. You can use what is referred to as an inverter. As you can see, this one is charging, and we'll definitely be talking about that. Now, the connection is definitely in that manner. There is a DC plus and a DC minus. If at all you interchange, what happens to it? Top boss, that is what we are going to discuss in this particular session. You can see the cable. Why is the sizing of that cable? So, why is it important to have such a cross-sectional area of a cable like that? All right, and you can look at the distance from the battery all the way to the inverter is not long enough, but again, the size of the cable that comes from the battery is huge compared to what we have exiting as the AC right there. Why is it like so? We also have this, which is always a great panel that is here with us. Now we'll go to talk about the load as well. So when you connect the load, let's say you have the lights. For instance, if this one is an AC, we have that bulb, we have that bulb, and we use these switches here. Does it mean that if at all we are using DC, we have to change everything? The bulb, the pipe work, the fixtures, the wires, or the cables. What does it mean if at all we want to have something different right there when it comes to the wiring or the entire setup, my top boss? That is what we are going to discuss today so that we can clearly understand the DC, you know. And when it comes to connecting directly the solar panel to the battery so that it can charge, we have an MPPT solar charge controller. What does that mean? Why have this charge controller? All right. Why have it between the solar is one as well as the battery? What does it mean, top post? Why is it so important to have that setup when you are connecting your solar charging system? And that is very important as we introduce the basics when it comes to solar, when it comes to charging. Basically, we will learn a lot about that. So today we are doing this live stream right here in our virtual shop, and I hope, my top boss, you will be able to enjoy our today's session. So smash that like button if you are ready to learn something from our today's live stream. This is our live stream, my top boss, and we are going to learn a lot together. I'm not saying that I'm the best, but all I can say is that I am here to learn from you as well, because definitely you will be guiding me on what I go wrong whenever we talk about solar. And if you know something much more than myself, I really do appreciate and, of course, recognize your knowledge when it comes to that. And I do welcome you. So, just to get us ready, let me still put that light on. I've connected it directly to my battery here, and I will be talking about that connection, the direct connection from the bulb, as you can see, and I will be talking about if you connect it directly from the battery, what implication does it have when, for instance, you have this charge controller, my top boss? Remember, this is a topic that is really in my heart because I have a lot of passion when it comes to this particular subject. And therefore, I believe that together with you, we are going to learn a lot because definitely you are also someone that is very much interested in the same topic. Thank you so much, my top boss, for tuning in. I can see a lot of you right in here. Thank you so much for finding time, and thank you so much also for the likes. Those who have already subscribed to our channel, appreciate it so much. It means a lot to us. So, what is DC circuit? The basics of positive and negative. Remember, when it comes to AC, we talk about live and neutral. And there is also something else which is earth connection. And therefore, for DC, it is usually very simple. And when we talk about positive and negative, it is something that we take with a lot of weight. I understand that even in AC, when it comes to connectivity, whereby you're supposed to connect the live and the neutral to either the source or to connect the appliances or devices, you are supposed to be very keen on that aspect, which is basically neutral and the live connection. All right, my top boss. Now, when it comes to DC, I take it as an example of a storage tank. It could be storing water, some chemical, or it could be storing gas. Now, when it comes to DC, we have battery sizes. And when I was introducing the video, I talked about this battery that is here. I cannot just lift it up. And I also have these two batteries. These batteries, this one and this one, are both rated 12 volts each. But there is a difference when it comes to amp hour. This is now the capacity, the guide to us understanding the capacity that a battery is able to hold. This is in terms of charge at any given point or at any given time. Something that I learned about batteries is that when the solar panel is charging it, or probably you're using an inverter like what we have demonstrated to charge this battery, it is not that there is some foreign charge that comes into this battery and then it is filled. No. What usually happens is the flow of electrons from positive all the I mean from negative all the way to positive. Because when you're using a battery and you connect a bulb, for instance, or a device, you connect on the positive what is supposed to be connected on the positive. For instance, if you have a DC bulb, I don't know whether I have a bulb here so that I can demonstrate. If you have a DC bulb, assuming that this one was a DC bulb, you definitely connect the positive to the positive terminal of the battery, and then the negative to the negative terminal of the battery. So that once the electrons are flowing from the positive side terminal, they will flow through the bulb into it through the positive connection. All right, and then out through the negative connection and back to the negative. So it's kind of the circuit that is the connection whereby there is a flow of charges, electrons flowing in that manner. Now when that happens, if at all the charges flow to the negative section, then it means that this battery does not have that potential difference, whereby from the positive to the negative, you require that PD, the potential difference, in order for you to say that that battery has maximum power to pump electrons and be able to supply the charge or the energy to, let's say, a device or a bulb. Now, in this case, what you need to do is to simply transfer the charges, the electrons, again from the negative to the positive, so that once they all move to the positive side, they can now be moved to the negative by the use of that battery. Could be connecting a sound system or connecting a lighting point, or basically a lamp. Thank you so much for those who are already joining in. I can see your comments. Hadassah Fashion says you are always on point with great information. Mike from Zambia. Thank you so much, Mike. So glad to have you here. I have Paul Lungu. Paul Lungu says, from Zambia, Lusaka, Luanga, I follow my great teacher. Salute to you, my top boss, all the way from Zambia, Lusaka. Our top bosses today come from Zambia, the top two. Thank you so much. I also have my top boss, Patrick Yeboah, says, please, what is AC circuit? So sorry, today we are talking about DC. I will talk about AC, and I've of course covered it in many of our videos. You can check it out, where I was introducing exactly that which is AC. So thank you so much for that. But just to go to it in a little bit, I will say that AC is basically alternating current. And the difference between alternating current and direct current is that alternating current is only generated and it is transmitted, but it cannot be stored. On the other hand, direct current is stored. All right. It doesn't mean that it cannot be generated and transmitted. For instance, in the case of a charger for me is basically an AC point of looking at things, because a charger does not store DC as much as it can give an output of DC, but it will not store it. All right. So we are talking about this basically a charger. So the connection, as you can see, you have the point where you get the connection for live and the connection for neutral. This is basically in a single phase setup. So once this charger gets its power supply from an AC source, it will, for this one, we have 240 volts. It will take 240 volts, but the output of a USB, which is the international standard, that is 5 volts. How does it convert, 5 volt, 240 volts, for instance, our case here in Kenya, from 240 volts, which is AC, all the way to an output of DC, 5 volts? Who knows? What is the mathematics there, or what is the physics that is happening there? From 240 AC voltage all the way to an output here, which is 5, only 5 volts. Remember, 5 volts is very, very little compared to what our battery here can give as an output. If we take one battery here, this battery is a 12-volt battery. And if we only connect one battery to charge our mobile phone, for instance, which requires only 5 volts, this mobile phone will be blown. All right? It might even explode. Why? Because that voltage is too much for our phone that requires 5 volts. Now, in many cases, you find that this battery here can be 5 volts, but it gives an output current that is very high. Does it mean that it will damage the appliance or the device? Top boss, there's a question that I asked that touched exactly on that, and your answers were split right in the middle. I asked this question: if you increase voltage through a bulb or through a lamp, or if you increased current through it, which one is likely to damage that lamp? If you increase the voltage? Will it damage the lamp? If we increase the current, will it damage the lamp? And actually, based on the answers that I was receiving, we were divided right in the middle. But my answer is voltage. Voltage has to be constant. If, for instance, you are dealing with a device that is strictly indicated, it has to be 110 volts AC, you must go by that. If at all you are using a power source or an outlet that gives 220 volts AC, you cannot connect it directly to a 110 volts AC. It will blow up. What you need to do is to definitely connect, have something that will be able to step down the output voltage from that source that you have from 220 volts AC to 110 volts AC so that it can be compatible. Otherwise, if you go and connect it directly, then you will definitely have issues on it. Now, when it comes to the direct current, this is a storage, for instance. I will take it as a storage in layman's language so that you may be able to understand it so easily, my top boss. Now, I began by demonstrating that. You see that battery, this battery that is here, it is 12 volts. This one is 12 volts. A combination of these two batteries will give 24 volts. But my question is, what kind of connection will result to a 24 volts? If this battery is 12 volts and this other one is 12 volts, what connection gives 24 volts? Is it a series connection or is it a parallel connection, my top boss? While at it, let me know from your view, what kind of connection is this? All right, whereby we have one terminal from this battery, which is actually a positive terminal, connected to the negative terminal of this other battery, leaving two opposite terminals on either batteries, the positive and the negative. So once you take the readings from here and here, you get a certain amount. Of course, that one will mean that we're taking the reading of only one battery, the one on this direction or side. And when you connect the probes of a multimeter on this side and on this side, you will definitely get a reading of the other battery, that is this one. But if you take a connection, if you place your probes on this terminal that is on this far end and this other side, you will be taking a reading of both the batteries. Assuming that you're taking the readings of the voltage readings, then it means that you are taking the combined voltage. So I've already answered one question right there, my top boss. All right. So these are some of the basics that can help you when you're dealing with DC connections. And when you're doing a solar installation, you are either connecting solar panels to the battery and you also have a load. We normally say that an electrician is a designer. For you to come up with decisions or for you to design a particular energy source, you first are a designer, my top boss. So in most cases, you'll find that you'll be required to do an electrical installation for solar, and you are probably required to have it in AC or have AC output. Now, you are the one to decide what is the output that you desire, and this is in terms of the wattage. You will really put that into consideration, and when it comes to that, you definitely have to factor in another important aspect when it comes to DC, which is the load. If you don't factor in the load, then that system will definitely fail, because when coming up with an electrical circuit, especially that is made of solar, like I said, It is important for you to bear in mind that you are working with it as if you have a storage tank somewhere. So this storage tank has water in it or whatever content that is in there. If at all the input is little, let's say you have little water coming into that tank, then it means that you must be very careful of the outlet or what is being consumed as maybe water or the content. For instance, if you have a smaller pipe that is an inlet to that tank, and you have a bigger pipe that is an outlet, definitely that water tank will not serve its purpose the best way, whatever size it is. This, in other words, means that if your solar panel is too small and the battery is too huge, or the battery is too small and the output, for that battery is too big, then it means that you will have a problem. So in another language, I'm saying if you have a tank and the outlet is small, meaning the solar panels that are charging that battery are not enough, or even if they are enough, they don't have a lot of sunlight exposure, there is a problem. That inlet is too small for that particular tank. Another issue is also on the size of the tank. If that tank is too small, it means that there is a problem. Because when we talk about too small, it definitely means that the appliances connected in that to that battery are also very huge for it. Let's say you have a battery, a single battery like this one, and you have that inverter, and you have connected, let's say, a refrigerator, you have connected a deep freezer, you also want to use it with a microwave, lighting, then it means that it is going to fail because one reason, the tank, the storage tank is too small. The outlet, the pipes that are outlet from that tank are very big, and they are also drawing, or that outlet pipe is drawing a lot of water at a go. Like, let's say in a given hour, there is a lot of water that is being used. Assuming that you have that storage tank and you have a lot of use in the kitchen in terms of cooking, you require a lot of water constantly every hour. And then you are probably doing the laundry and you are also doing irrigation. Then, if that water tank is too small, it means that even the water that is in there, regardless of uh, how fast the water is incoming, it means that that water will run out very fast. So what you need to do is to ensure that the storage tank is too big. So in this manner, you ensure that that battery bank is bigger. Either have several batteries connected in a series manner so that you can achieve high voltage, and you also ensure that that battery bank can be able to sustain whatever load is connected for the desired time that it will be in use. For instance, if you have a microwave that is run 30 minutes every day, of course, 30 minutes to heat food is sounding ridiculous. But again, my talk was when you are calculating the usage of that microwave, you really have to ask how long is the microwave in use within 24 hours. So, if you're giving someone a quotation for solar, these are some of the questions that you must bear in mind and you must ask your client. For instance, a client asks for a quote. Many clients have come to me and they say, I just need a quote. I need this quote for a 3 bedroom house. Do it. Or a 2 bedroom house. I don't have a bigger house. Give me that quote. No, 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 no. I always ask them, what appliances do you have? All right. Okay. You have given me the list: a fridge, a microwave, a deep freezer. All right. For each and every appliance that you have in your house. What is the rating? Another important factor. You have a fridge. Is it rated at 1.5 kilowatt hour? That means in 1 hour it is consuming that what amount of power. Again, for how long is it in use? Why is it important? There are refrigerators that go on and off within the day. All right. So when it is on, how long does it run? When it is off, how long does it remain off in a given hour, in a given day? These are very important questions when it comes to designing of a solar system, whether it is a backup system or it is the primary source for power. These are very important questions that you need to ask the client. Now, another thing is, for instance, when I was talking about the microwave, let's say it heats food 5 minutes, 3 minutes, 4 minutes. For instance, in the morning, it heats for 15 minutes. And then during lunchtime, it heats for another 10 minutes. So those are 25 minutes. And then in the evening, the family will probably use it for 5 minutes. So that is basically 30 minutes. This is very important because you know what? If that microwave is rated at 1000 watts, all right, that means that it is 1 kilowatt. So if you do the calculation, you divide that as well into the number of hours, and you find that you really require to factor in the total load. So if you arrive at, let's say, 3 kilowatt, so does it mean that a 3 kilowatt power system is enough for that home? Absolutely no. Why? Because there are days that you must assume that they will go beyond 3 kilowatts. All right. So when it comes to that, you have to come up with a system that is bigger than that. And the next one that you probably might consider now, depending on the client, might be a 5 kilowatt power system for them. So if you have the 5 kilowatt power system, that will be able to cater for their needs, of course. Now, from there, we now go to solar panels. All right. So again, when it comes to the load, we have figured out that this is a 3 kilowatt load. We have figured out that we need a battery that is definitely able to supply that, and also the inverter. When we get to the solar panels, the main question that we ask here is, within a single day, is it able, that solar combined PV is photovoltaic, the combination of the solar panel output, is it able to produce 5 kilowatt within a day? Also within that day, we go down again to 5 hours. Within 5 hours of sun or sunlight, or within 5 sunlight hours, can we be able to get 5 kilowatt? So in essence, you must be able to come down to this. Within every hour, you must be able to get at least 1.5 kilowatt from these solar panels. That is very, very important. Eric Anzane, it's so good to see you again here on our live stream on YouTube. Eric Anzane, I give you a special salute. You are always interacting with my content, and it means a lot. Every time that I post, I see you interacting with it. I really do appreciate. Eric Anzane is our top resident electrical engineer. Mm, mm, mm. Whenever I post content and someone seems to be a little bit confused about what I am talking about, and they have asked, even before I respond, Eric is there to, give some guideline, and therefore that is why I refer to you as our resident top engineer. Thank you so much for joining in and also finding time to come in here. Earlier, we were together on our Facebook live stream in the morning, and thank you so much for joining in. Yeah, So that is very important coming from the solar panels. So these solar panels must be able to produce that power. Things are not as much complicated nowadays because we have even solar panels that are really advanced. The other video I was showing you was on the bifacial solar panels, whereby you have solar panels that charge on both sides. You see, like this one is an old school solar panel monocrystalline whereby it will only charge on one surface, the top one. So if you have these panels laid up in a roof, you only harness power from one surface, which is the top. But again, when it comes to bifacial, you have both sides. So even the orientation of those solar panels means a lot. And therefore, that is why I usually insist on us understanding the emerging technology, being familiar with it. Assuming that a client has uh, supplied you with a bifacial solar panel, and then you mount it in such a manner that the bottom part or the bottom section does not have exposure to sunlight, you have wasted that material on that product. And as I was saying that we are designers. So when you are designing a solar plant for them, you ensure that if at all you understand the concept of bifacial, you understand that if you incline a solar panel in this manner, for instance, and let's say the sun is coming from this direction, it will be able to utilize this particular section maximally to charge the battery. And when the sun is on this direction, it will be able to maximally utilize the cells that are on this below section to be able to produce as much energy as possible. So you have multi-directional charge. Again, with the advancement of these solar panels technology, even when this solar panel is exposed to only light from the start of the day, it is already charging that battery. Meaning that as long as there is presence of light, even without the sunlight, that battery is charged by that solar panel. Isn't it amazing? That is such an incredible technological advancement. So that is on that. And when we get to talking more on solar, the solar sizing matters to do with the connectivity. Is it parallel? Is it in series? And what does that mean? We will definitely delve deep into the nitty gritty in terms of the voltage, the current, and open voltage, open current, and all that we'll be talking about. Today we are just laying a foundation for the same, my top boss. So when we talk about 200 amp hours for this battery, it's the same as talking about the tank. If the tank is too big, it means that it will be able to hold a lot of storage water or whatever is in there. And if at all we're talking about this battery, for instance, this one is a 12-volt, but amp hours are 7, meaning that within 1 hour it can be able to give us at max 7, assuming all factors are constant. It will be able to give us 7 amperes, and it will be drained completely. This one, within 1 hour, it can be able to give or support or supply 200 amperes at assuming also all the factors are constant. So within 1 hour, this battery will give us much less compared to this battery that is here, my top boss. So I hope you are understanding the difference when it comes to amp hours as well as the voltages. So amp hours is basically the amount of current in an hour, all right? And therefore voltage is basically PD or potential difference. What about the resistance? We have internal resistance, and that resistance is basically between the cells. Top boss, if there is something that you are getting so far, smash that like button. Thank you so much for joining in. If you'll be watching this video in a recorded version, kindly smash the like button. And if you have not subscribed to my channel, please, my top boys, subscribe to my channel so that you don't miss any content that we put out, as well as any live sessions that we will be engaging in. Now, I have also a power bank here. A power bank, what does it mean to have a power bank? For instance, this one is rated 2.1 amp hours. Again, much less than what we have here. The output voltage is 5 volts. So as you can see a USB there, whenever you see a USB, in most cases you just know that that output that you expect there is 5 volts, and this is definitely in DC. All right. So if you connect a phone here using the USB cable, it will be giving an output of 5 volts, charging your phone at 2.1 amperes max. So if you connect again another phone, so those are two phones draining 2.1 amperes from this battery. So that will mean that, of course, the voltage will remain the same, but again, you will minimize the time at which that this power, I mean the output of the power from this power bank. Why? Because if in 1 hour it has to give 2.1 amps, meaning that is uh, the max it can give in 1 hour. If you connect something else, if you add a phone to charge, it means you have connected two battery, two outputs there. The voltage is in parallel. It means that the voltage will be constant, yes, but but this current will only be supplied to those two phones in 30 minutes, and this power bank will be dead. All right. Or if at all you are charging those phones for 1 hour, it means that it will be very, very slow, because the amperes will have to be split into two. So instead of having 2.1 amperes going to the phones, you will have, is it 1.05? Yes, if I'm not wrong, my top boss. So that is on that. Also, let me touch something on this other power bank here. You might be familiar with it. This power bank is definitely, the earpods. So if you are listening to some music, you have to charge your earpods, and this is also another power bank. And this earpod here has a battery inside as well, very small battery in there, a power bank as well, so that it can be able to, supply power for its use. And therefore, when you also connect it inside here, it will start charging, because this one is also a power bank. All right. So the smaller the size, it also goes without saying that again, the capacity of that particular battery is small. But when it comes to chargers, it gets even interesting. Chargers, like I said, are not a storage, or you cannot compare them to the normal DC storage. As much as they have an input of AC and give a DC, they are not storage. A battery has a storage of DC, and it gives out a DC output, but it can be able to hold charge. For this one, it can only give an output as long as it is connected to an AC outlet. So the size of this charger here is very small, as we can see, and its input is between 100 to 240 volts. Such an amazing innovation from Apple. And It can be used in that system whereby you have 110, for instance, in the America, and it can also be used for us here in Kenya where we have 220 volts AC, because it is indicated it can be able to handle 100 to 240 volts AC, 50 stroke 60 Hz, all right? And then the output is 5 volts, 1 ampere. Mhm. Now, when we check this one is a bigger charger. So this bigger charger here takes in 200. Yeah, also it can also take a 100 to 240 volts, and it can give a DC output of 5 volts, 3.4 amperes. So basically, it is per USB port, it is giving 1 ampere. All right. So the output is actually 3.4. So if you only connect one device here, let's say a phone, it will charge very fast. But if you connect 3 phones at the same time, therefore it means that the 3.4 amperes are, are shared across these USB ports here, and therefore there will be something that we refer to as slow charge, because for every 1 hour you are only getting 1 ampere. All right. So this uh, device here, or basically this adapter here, gives 1 amp hour. The same happens here for each and every port. All right. So that is a very important thing when it comes to the DC, my top boss. So I don't know whether you have a question when it comes to that. I will be so glad to respond to it, my top boss. So thank you so much for joining in. And if you'll be watching this video, my top boss, kindly I request your like as well as your subscription. Now, when it comes to charging using solar directly to the battery, there is what we refer to as a charge controller. A lot to learn from a charge controller. First, if you have connected the solar panel directly to the battery, it means that with any amount of charge, that solar panel is able to charge this battery at all times, as long as it is during the day, meaning from 6 a.m. all the way to around 6:30 p.m. or almost 7. The battery is being charged continuously. Now, how will you know that indeed the battery is fully charged, in layman's language again? For you to disconnect it, it is very hard. Myself, when I was growing up, we would take our solar panel outside and the battery, have it charged, and then get it back to the house. Of course, due to security reasons, back in the days, solar panels were very, very expensive and sort of lucrative, or um something worth having as part of your possession. But again, the point is, once there is presence of sunlight striking those PV cells, it means that there is continuous flow of charge to the battery. Now, the battery might be already filled and the solar is still charging this battery. It will definitely damage it. All right. So you require this charge controller, a wonderful innovation here. I'm not saying this one is the best. There are so many charge controllers out there in the market, but using this one, the charge controller is able to regulate the incoming charge to the battery, so that once the battery is fully charged, this charge controller will be able to disconnect that. Right. So in case the battery is fully charged, this charge controller will not allow more charge to the battery, it will simply disconnect it. Even though there is presence of sunlight, but it will not allow more charge to the battery. When the battery's voltage, current has gone low or is again in another layman's language, when the capacity of not the capacity, when the charge is dropping, this charge controller will again automatically switch on or close the circuit between incoming solar power to the battery so that it will be able to allow charge to flow into the battery and be able to charge the battery until when it is full again. Remember, this can happen simply because even when the battery is idle, it can lose charge. Have you ever find a situation whereby you charged your phone, it was fully charged, and then after some time, you have not even used it, but you discover that the battery, the phone indication of the battery is around 60%. So you wonder what happened because of discharge over time. So if you have a battery and you are probably even not using it, it will also do the same, it will discharge. So this charge controller automatically detects all these events and it reconnects the solar to continue charging the battery once more. There was this phenomenon back in the days, it was said that once the battery is fully charged by the solar, when it gets to the dark, the solar starts draining the charge from the battery. I'm not sure about that phenomenon. I don't know what about you. Have you ever heard about it? And or is it the first time that you're hearing about it? It used to be said that the battery will start drain, the solar panel will start draining the charge. So I'm not so sure about that. All right. So this charge controller will prevent any of that issues from happening. There's something also important about this charge controller. Rated battery starts from 12 volts, 24 volts, 36 volts, 48 volts, and 60 volts. Starting from there, what does that mean? This battery is a 12 volt battery. Now, a combination of two batteries of these similar will, of course, connected in series, will give an output voltage that is 24 volts DC. Now, if you connect to a 12 volts solar panel, that one will be a disservice because that solar panel will have a struggle in charging that battery, right? Because the voltage is very low, the batteries are very highly rated in terms of voltage. So again, you might be having batteries that go up to 60 volts, you know, or a single battery that is rated 60 volts. This charge controller is connected to it. And the good thing about this charge controller also, the output voltage is uh, based on the output voltage is actually 12 volts. Yes. So that anything that you connect across these output or on the load section is has to be at 12 volts. So be it a lighting point, be it a sound system, or probably you're feeding an inverter, it gives an output of 12 volts. That is very constant. And maximum PV input. Maximum PV input is 600 watts. All right. So 600 watts, and the voltage again is 12 volts, 24 volts, 36 volts, 48 volts, and 60 volts. So this one is a small charge controller. Another important thing about it is the rated current. Very important. The rated current is at 50 amperes. Now it can be able to handle, the charge from the solar panel all the way to the batteries, and what is going through this charge controller can be able to handle up to 50 amperes, and 50 amperes is a lot. So this charge controller can be able to handle up to that. But again, I'm not saying that this one is the best. Of course, we have other MPPT charge controllers that can be able to handle even large solar system. Now, another important thing that I have just mentioned also is on the input, the PV input. Because, for instance, this is a 48 volts solar panel, right? So a 48 volt solar panel, when you connect it directly to this battery, you will have issues. It will damage the cells of that battery. And that is why a charge controller comes in handy. It will be able to take, because this PV input starts from 12 volts, 24 volts, 36 volts, 48 volts, up to 60 volts. And as you can see, 48 volts from this PV or from this solar is within that range. All right. So if we have connected the solar panel through this charge controller, it will be able to control the amount of voltage that is getting into the battery by simply ensuring that the voltage getting into the battery is within that range between 12 volts or even less, all the way to around 19 or even up to 24, and not more than that, regardless of the fact that this solar panel is able to give that, so that it will maximize on the current output. So that, remember, what we're interested in is the current, all right, for us to achieve maximum voltage for charging this battery. So if the charge controller is able to get that and be able to get to the required or the desired voltage for this battery, which is safe, then it will be able to charge the battery without any complications or without much issues. All right. Yeah, so that is about that. When it comes to connecting a charge controller, of course, I will do a video on that, but just to briefly mention, first things first, you cannot connect a solar panel directly to the charge controller before you connect the battery. The first thing to do is to definitely connect the battery, feed it with the source. So you connect the battery. The battery is usually at the center. So if you are able to look at that charge controller there, those two terminals at the middle, of course, we have the first set of terminals, and then we have the second, which are in the middle, and then we have the third, which are at the far end. That is the load. So this is PV, battery, and load, right? So the connection is usually you start with the battery. Now, whether you choose to connect the load, then that is up to you. But the one easy way to damage the charge controller is by connecting the PV. Why? Who can give us a reason as to why that happens? I don't know whether we are able to note that if you connect solar panel before you connect the battery, you can quickly damage this charge controller. Why is it so, my top boss? Who knows? On the chat, I still have my top bosses, and I'm really grateful. Thank you so much for joining in. Mhm, mhm. Who can be able to tell why is it a mistake to connect the PV or solar before you connect the battery? In fact, when you read the manual of this charge controller, warning is that you must ensure that before connecting solar panels or the PV, must ensure that you first connect the battery. and so that is very, very important. When it comes to these USB ports here, these USB ports here are only an output for USB purposes. It could be charging, you know, most likely it is charging, but this charge controller is not programmed after it is already assembled. That is what I'm sure of. It is just an output. It is a DC 5 volts to amp output for that USB, meaning that when you plug in something there, you get an output voltage of 5 volts and 2 amperes. Now, what is the power rating of such a setup? 5 volts and 2 amperes. Because this is another way of learning the basics of, you know, DC, right? Top bus. 5 volts, 2 amperes gives what power output? Say that P is equals to IV or I squared R. So because we have known values here, which is it values, or we know we have known, cannot say parameters, but we have we okay. Let me just make it easy. We know the voltage, we know the current. The voltage being 5 volts and current being 2 amperes. So basically, P, which is equals to IV or current multiplied by voltage, we definitely have 10 watts. So within an hour, we get 10 watts. So that is very incredible from that to just learn. Mm, mm. Something else that I probably talk about when it comes to DC is the issue of heat. When you connect DC sources, especially the battery, and you connect them to loads, one thing that you must ensure that you factor in is the issue of heating. Heating comes due to resistance, very high resistance generated there. And if you're not using the right or the correct cables in that setup or in that wiring, there's definitely going to be an issue. And resistance when it comes to DC is a very, very major issue, because that resistance, as we know, it will cause the wire to heat or to overheat. All right. So the surest way for you to compensate that is to increase the size of the cables that you are using. Between the battery and the inverter, as I showed when we were starting the video, is that the cables and even the terminals have a lot of emphasis there. The terminals are very big so that they can be able to accommodate the huge cables that are incoming. When it comes to the AC output of that inverter, there is no big problem there. The cables are smaller in size. Why? Simply because AC can travel longer distances and without very high resistance. The same is usually witnessed when we are talking about the national grid and power distribution. You find that even the conductors that are being used to transmit power are smaller in size, because that is an AC transmission, can travel for longer distances and without a big issue when it comes to the resistance. And for DC, there are a lot of losses, especially when we are talking about longer distances. So if you have a longer distance whereby that power has to be transmitted, definitely you must factor in resistance. In vehicles, someone might ask, the vehicles normally have the wiring in DC, or cars basically have their wiring in DC, because again, if you factor in the distance around a vehicle from, let's say, one lamp to another controller or to the fuse boxes, and also to, let's say, the battery or the ignition, that distance it's not that big, and so that is why it is important for uh, us to consider that factor. But again, something that is very, very important when it comes to the vehicle wiring, I have a lot of interest in that. I love how that setup is always about, because you will find that there are a lot of cables in a car. And for me, I think it is not a complicated wiring if someone decides to, explore or learn about it, because it is basically you understanding what is the purpose of this particular set of cables or this wire, what is its purpose, where is it from, where is it going to, and uh, that is basically it. Now, when it comes to again a vehicle, it is important for you to factor the material of the wire or the material of the cable. If that wire is made up of material that causes high resistance, there will be heat generated in there. Considering the fact that the engine also generates its own heat, that is another recipe for disaster. And that is why, if you have noticed, the cables that are in a car or in a vehicle have a lot of emphasis on one important thing. What is it? Insulation. And you find that in most cases, this insulation, whenever it is subjected to heat, it hardens. All right? It hardens so that it will not melt away, causing short circuits. Unless the person that was doing the installation was not aware of this factor, the cables that are supposed to be purchased for vehicle or automotive wiring is completely different from what we do have. Because when we talk about wiring in a house or in industrial setup, you it's usually very much basic. It goes through a conduit system, and the conduit system is in concrete, so chances of having issues with temperatures are actually minimal. But when it comes to a vehicle, there is an exposure of very high temperatures. The same can happen in an industrial setup whereby there is a lot of cooking or there's a lot of heating. Sorry, there's a lot of heating in an industrial setup. The choice of cables matters a lot. When it comes to domestic setup or business setup where you have cooking taking place, again, the cables that are in use in there must be highly insulated. This is so that the issue of heat is factored in reference to the insulation as well as the transfer of power. Because again, when the temperature is too high, there is a lot of collisions, and these collisions will definitely hinder the flow of electricity or basically current. All right, there we have diverted a little bit, but basically, those are some of the things that you encounter when we are talking about the DC. A lot more I will talk about, especially touching on solar, touching on the battery, touching on the storage basically, and also sizing up the correct solar that can be used when it comes to designing a power energy, solar energy for either domestic use or probably industrial use. I had laid a foundation and I talked about three-phase solar power, and most of you were asking more on the configuration of the inverters to specifically give different phases. For instance, here in Kenya, the red phase, the yellow face and the blue face. All right. I usually confuse between yellow face and blue face. Which one is in the middle? But it is definitely the red face, the yellow face, and the blue face. So thank you so much, my talk boss, for joining in. And if you'll be watching this video on a recorded version, I also appreciate your time. Smash that like button and also subscribe to our channel so that you don't miss any episode. And until next time, I will be glad to have your time. Daniel Kiplagat says, how does one mount a change over automatic? Daniel Kiplagat, I will definitely be addressing that in our subsequent videos where I will be talking about changeover switching between the generator and the national grid. We also have a set whereby you can have a generator, a solar system, and the national grid. And there is also that whereby you can prioritize, is it the solar, is it the generator? Of course, it might be difficult for you to prioritize the generator because of the consumption. Or are you prioritizing the national grid so that once the national grid is out, you either have the generator coming in first or the solar backup. All right. So thank you so much for that brilliant question, Daniel. I will definitely be sure. I'll definitely be talking about it. But for now, that has been my time. I really did enjoy that session with you, my talk boss. Thank you so much for keeping me company. Until the next live session or our content, my name is John Gatehi, and this is Top Heights Electricians PLC. Thank you so much. Until we talk again, goodbye for now.